So for E, greater inequality of income within a country, this is wrong. Inequality is supposed to be solved. So the answer is C. Okay, we're almost there. One more page to go. So in this neoclassical assumption of constant returns to scale, it means that the GDP per capita increases with economic growth. It does not work the other way. See, so when economic growth occurs with increased GDP per capita is wrong. Because only when there's economic growth, living standards will increase. It doesn't work the other way. For C, living standard must decrease with economic growth is wrong. It's supposed to be increased. D is wrong as well because it's supposed to be increased. And then what label augmenting, if you're wondering, it means that for the same amount of L, same amount of L, you actually produce more. So things become more efficient. So number 4, which of the following is not a feature of the increasing returns theory of economic growth? So this is talking about the endogenous growth model. So firms that first develop new investment opportunities receive low initial rates of return because of high fixed costs, which is true because, for example, when there's the firm who is the first one to develop new things, they actually have to spend a lot on R&D. So they are going to receive a low initial rates of return because of the high R&D costs. For B, investors who follow pioneer investors, that means the first investors, face a higher investment cost and therefore decreasing rates of return, which is wrong because let's say the first firm they managed to develop something new, but then it will be cheaper for the other firm to follow because they are able to learn from the first firm's experience and mistakes. That's why they will have a higher rates of returns and lower investment costs. So for C, so answer is B. Once a technological breakthrough has been made, new investors earn high rates of return since this technology is usually available to them, which is correct. Acceptability of new products takes a learning by using process by consumers. So let's say if there's a new product coming out, in the beginning a lot of consumers will they don't know how to use it, right? So there will be always a few people who go first to try the new things first, and then if it's good, then other people will try to follow and learn it. So that's why this is correct. When more people learn it, that means more people accept it. So last question, number 5. So there's Y is real GDP, T is state of theory, K is capital, L is labor. So for parts A to C, remember labor changes but the rest remain constant. Labor changes, capital technology is constant. So in order to calculate this, you just sub this into the equation, and then you get this is 52, this is 60, and 61.7. Just sub it in. And then for B, the marginal productivity of labor is defined as a change in real GDP divided by the change in labor use. So we have 3 ranges. So for 10 minus 15, 10 to 15, 15 to 20, and 20 to 25. You can see that output increases by 9.6, right? You just use this one, divided minus 52 minus 42.4. 9.6, and then for the 15 to 20 you get it increased by 8, and then 20 to 25 it increased by 7.1. Just minus it. So 60 minus 52 you get 8, 67.1 minus 60 you get 7.1. So the marginal productivity of labor, and defined as MPL, will be 1.9, 1.6, and 1.4. How do you calculate this? Is when you use your change in real GDP output divided by your labor use. So it's 9.6 . Next is wait, strange. Oh yeah. So it's like cost change in labor use, right? They increase by 5 each section. So use output increased by 9.6, which is a change in real GDP, divided by 5, you can get 1.9. And then for this one, it's like use 8 divided by 5, you get 1.6, 7.1 divided by 5, get 1.4. So for C, as labor increases, what happens to the living standard as measured by real GDP per capita? So you need to see, so what's the average output per worker? So when there's like 4, for when labor is 10, you need to use the real GDP, 42.4 divided by 10, and then you get 4.2, which is the average output per worker. Then for the next one is 52 divided by 15, 60 divided by 20, 61.1 divided by 25. And over here you get 3.5, 3, and 2.7. As you can see, the living standard is decreasing as labor increases while capital is constant. So what about part D? When labor and capital changes but technology remains the same. So for the same, this one you just sub the equation, you get 63.6, 84.9, and 106.1. So what happens to change in Y for successive proportionate increase in labor and capital? So as you can see, when output increases by 50%, right? From 42.4 times 50%, it becomes 63.6, right? So, but then the same thing happens for labor and capital. It also increased by 50%. And then from 15% to 20, from 15 to 20, 30 to 40, they increase by, so over here is 50%, over here is 33%. The same thing happens for real GDP as well. It increased by 33%. So this is what they call by constant returns to scale. This is a part of the neoclassical growth model, where when L and K increase the same amount, real GDP increase the same as well. So what happens to standard living as measured by real output per worker? So because of technology remain constant and labor capital they increase the same, the GDP per worker remain constant at 4.2. You can check and see. So it's like 42.4 divided by 10, you get 4.2. And then 63.6 divided by 15, you get 4.2 as well. It's the same as 84.9 divided by 20. Okay, so last question. Then you're done. Yay. So for this one is when they change technology while labor and capital is 20. So you sub the equation inside, you get real GDP is 80. So what does this mean? It means when T increases Y by 20 with no change in L or K, which means that more stuff become more efficient compared to when there's like 20 labor and capitals, technology is 3, you only get 60. But when technology is 4, while labor and capital is the same, you get 80. So this is the technology growth they mentioned in the neoclassical growth model. Alright, yeah, so thank you for staying. So if you guys have actually any questions, you guys can like find me. Here's my my contact number actually.